Now here the question is, if alpha and beta are two distinct real roots of this equation, ax cubed plus x minus 1 minus a equals 0, where a is unequal to minus 1 or 0, and alpha and beta, they are unequal to 1, then we need to find the value of this limit. Limit x tends to 1 by alpha 1 plus a x cubed minus x square minus a upon e to the power 1 minus alpha x minus 1 into x minus 1. Now if we put x equal to 1 in this equation, we'll get a plus 1 minus a equals 0. That means one of the roots of this equation is 1. So roots of this equation are 1, alpha and beta. Now we'll find the equation whose roots are 1 upon alpha and 1 upon beta, and for that we'll replace x with 1 upon x. So it'll be this a upon x cube plus 1 upon x minus 1 minus a equals to 0, or we can write this equation as 1 plus a x cube minus x square minus a equals 0. So if we take this limit x tends to 1 by alpha, then 1 plus a x cube minus x square minus a, it will be 0, as 1 upon alpha is one of the root of this equation. So basically now we know that this equation has three roots, 1 upon alpha and 1 upon beta. So we can write this limit L as limit x tends to 1 by alpha, and if factorize it, we can write this as 1 plus a into x minus 1, x minus 1 upon alpha, x minus 1 upon beta upon e to the power 1 minus alpha x minus 1 into x minus 1. Now this x minus 1 will cancel. We can write this as limit x tends to 1 by alpha. Now it will be this 1 plus a. Here we'll take minus common. So it will be this minus and then 1 minus alpha x, and here will be this beta x minus 1 upon e to the power 1 minus alpha x minus 1 into alpha beta. Now this is standard limit e to the power x minus 1 upon x. So it is 1, and we'll put x as 1 upon alpha. We can write this limit L as minus 1 plus a beta upon alpha minus 1 upon alpha beta, or it is 1 plus a into alpha minus beta upon alpha square beta. So value of this limit is 1 plus a into alpha minus beta upon alpha square beta. Now 1, alpha and beta, they are roots of this equation. So if we find their product, 1 into alpha into beta, it is minus c upon a, which is 1 plus a upon a. So we'll put alpha beta as 1 plus a upon a. So it will be 1 plus a into alpha minus beta upon alpha, and it will be 1 plus a into a. So it will cancel. So value of this limit, it will be a into alpha minus beta upon alpha. Now we compare it with this given limit, then we can write value of L must be 1, value of K must be 1. Now we need to find the value of K into L. Value of K into L is 1. Now here the question is, we are given this limit n tends to infinite, and we can write this numerator as this summation r varies from 1 to n r to the power 1 by 3, and this is n to the power 7 by 3, and plus this summation r varies from 1 to n 1 upon a n plus r whole square. Now here we'll take n square common, so we can write this as this limit n tends to infinite. Now n square will cancel with n square, we'll get n to the power 1 by 3, and we'll take n to the power 1 by 3 with r to the power 1 by 3. So we can write this as this summation r varies from 1 to n, and it will be this r by n to the power 1 by 3, and here will be this summation r varies from 1 to n, that is 1 upon a plus r by n whole square. Now what we'll also do is we'll multiply numerator and denominator with 1 by n. Now it satisfies all the three conditions for limit of sum. Now we have n tends to infinite, we have 1 by n, and we have r by n. So we'll replace r by n with x. So it will be this integral and then x to the power 1 by 3 dx. Now when r is 1, it is 1 by n, and 1 by n is 1 by infinite 0, and upper limit is n by n, which is 1 upon, and for this also we can write this integral from 0 to 1 dx upon a plus x whole square, and it is given that it is equal to 54. Now it will be this x to the power 4 by 3 into 3 by 4 from 0 to 1, and here it will be minus 1 upon a plus x from 0 to 1, and it is equal to 54. Now this is 3 by 4, and here it is 1 upon a minus 1 upon a plus 1, and it will be equal to 54. Now this is 18. So we'll get a square plus a equals, which is 8 into 9. So it will be this a plus 9 into a minus 8 equals 0. So value of a is either minus 9 or value of a is 8. So the options are A and D. Now for this question, we are given two functions fx and gx, and we need to find left hand limit and right hand limit of g of fx at x equals 0, and hence find this limit x tends to 0 g of fx. Now if we look at left hand limit, now left hand limit at x equals to 0 is x tends to 0 negative. Now x tends to 0 negative means x is less than 0, and if x is less than 0, then fx is going to take this definition. So it'll go to 2 minus x. Now since x is negative and it is 2 minus some negative number, this f0 negative, it will be greater than 2. So it'll take the value 2 positive. And when fx is greater than 2, then gx is going to take this definition. So this plus 2 will go to x minus 5, and 2 minus 5 is minus 3. So its left hand limit will be minus 3. Now if we look at its right hand limit, which is x tends to 0 positive, when x is greater than 0, it will go to x upon sin x. Now we know that sin x is less than x, that means x upon sin x, it is greater than 1. So basically this is 1 positive, and if it is greater than 1, then it will go to this definition, which is x square minus 2x minus 2. Now if we put x as 1, it will be 1 minus 4, which again is minus 3. Since both left hand limit and right hand limit, they exist and they are same, value of this limit is minus 3. Now here the question is, we need to find this limit x tends to minus infinite, and this is 3x to the power 4 plus 2x square sine 1 by x plus mod of x cube plus 5 upon mod x cube plus mod of x square plus mod of x plus 1. Now since x is minus infinite, that means x is less than 0, and when x is less than 0, then mod of x is simply minus x. So we write this as limit x tends to minus infinite, and this is 3x to the power 4 plus 2x square sine 1 by x minus x cube plus 5 upon minus x cube plus x square minus x plus 1. Now we'll divide everything with x cube. So we can write this as limit x tends to minus infinite, and here will be 3x plus 2 upon x sine 1 by x minus 1 plus 5 upon x cube, and here will be minus 1 plus 1 upon x minus 1 upon x square plus 1 upon x cube. Now everything is sorted other than this x. So we'll multiply it with sine 1 by x. We can write this as limit x tends to minus infinite 3 into. Now we'll write this as sine 1 by x into x, and which can also be written as 1 by x and plus 2 by x sine 1 by x minus 1 plus 5 upon x cube divided by minus 1 plus 1 by x minus 1 upon x square plus 1 upon x cube. Now when x tends to infinite, sin x is 0, so it is 0 upon 0 form. So this limit, it is 1, it will be 0, this is minus 1, this is 0, all of them, they will be 0. So this limit will be 3 minus 1 upon minus 1, which is minus 2. So answer to this limit is minus 2. Now here the question is, we need to find this limit x tends to infinite cos 2 pi x upon 1 plus x to the power a whole to the power x square if a belongs to R. Now first we'll check its form. Now this is x upon 1 plus x. When x tends to infinite, it will be 1. Now cos 2 pi is 1, and 1 to the power x square is 1 to the power infinite. So it is 1 to the power infinite form. That means we are going to use this shortcut directly. So it will be this e to the power, and then this limit x tends to infinite x square into cos 2 pi. Now we'll actually write this as 1 plus 1 upon x to the power minus a, and then minus 1. Now here we'll use binomial expansion of 1 plus x to the power minus n. So it will be this e, and then this limit x tends to infinite, and then x square, and we can write this as cos 2 pi 1 minus a upon x, and then it will be minus a minus 1. So it will be this a into a plus 1 upon 2 1 by x square, and plus higher power of x, and then minus 1. Now cos 2 pi minus theta is cos theta. So we can write this as e to the power limit x tends to infinite, and we'll take minus common. So it will be this x square 1 minus cos 2 pi a upon x plus other terms. Now we'll rewrite this as e to the power limit x tends to infinite minus x square 1 minus cos 2 pi a upon x. Now we'll multiply and divide everything with 4 pi square, and then a upon x whole square. Now we have to multiply it also. Then will be this 4 pi square a upon x whole square. Now this becomes a standard limit, which is 1 by 2. So we can write this as e to the power, and then this limit x tends to infinite minus 1 by 2 into x square into 4 pi square a upon x, a plus 1 upon x square whole square. Now you multiply this x square, we'll get this a square. So it will be this e to the power minus 2 pi square into a square, and that is the answer to this limit. Now the question is, find the value of a, b and c so that this limit is equal to 2. We are given that this limit x tends to 0, a into e to the power x minus b cos x plus c into e to the power minus x upon x sin x, and it will be equal to 2. Now we'll solve this question using series expansion. So we'll write this as limit x tends to 0. Now this is a. Now e to the power x is 1 plus x square upon 2 minus b. Now cos x is 1 minus x square upon 2, and plus c, e to the power minus x is 1 minus x plus x square upon 2 whole divided by x, and sin x is x minus x cube upon factorial 3, and this must be equal to 2. Now since x tends to 0 and answer is non-zero finite, that means minimum power of x in the numerator must be same as minimum power of x in the denominator. Now we know that minimum power of x in the denominator is 2. So in the numerator also, this minimum power, it must be 2. That means all the powers of x which are less than 2 must have coefficients 0. Now we look at this constant term. This constant term will be a minus b plus c will be 0. And if we look at coefficient of x will be a minus c, and it will also be 0. Now once we have eliminated all the lower degree terms, then answer to this limit will be coefficient of x square in the numerator upon coefficient of x square in the denominator. Now coefficient of x square in the numerator will be a by 2 plus b by 2 plus c by 2 upon 1, and it will be equal to 2. So we get a plus b plus c equals 4. Now a equals c and b equals 2a. So we get 4a equals 4. That means a and c, they are 1, and value of b is 2. Now here the question is, we are given this function fx as log x square plus e to the power x upon log x to the power 4 plus e to the power 2x. Now if this limit x tends to infinite, fx is L, and x tends to minus infinite, fx is M, then find the relationship between L and M. Now for L, it will be this limit x tends to infinite log x square plus e to the power x upon log x to the power 4 plus e to the power 2x, which is infinity upon infinity form. We'll use L'Hopital's rule, so it will be this limit x tends to infinite, and then we can write this as 1 upon x square plus e to the power x into 2x plus e to the power x, and here it will be 1 upon x to the power 4 plus e to the power 2x into 4x cube plus 2 e to the power 2x. Now we can write this as limit x tends to infinite 2x plus e to the power x upon x square plus e to the power x into x to the power 4 plus e to the power 2x upon 4x cube plus, and this is 2 e to the power 2x. Now here we'll divide everything with e to the power x, and here we'll divide everything with e to the power 2x. So we can write this as limit x tends to infinite 2 x upon e to the power x plus 1 x square upon e to the power x plus 1, and here it will be x to the power 4 upon e to the power 2x plus 1, and this is 4 x cube upon e to the power 2x plus 2. Now we know the standard result that this limit x tends to infinite, x to the power n upon e to the power x, it is 0. And it is very easy to prove. This is infinity upon infinity form. So we'll keep using L'Hopital's rule. It will always be infinity upon infinity form. So if we differentiate this n times, we'll get this as factorial n upon e to the power x. Now this is factorial n upon infinite, and which is 0. So this limit will always take the value 0. So this is 0, this is 0, this is 0, this is 0. That means from here we can say value of L is simply 1 by 2. Now we'll find the value of M. Now for M we have this limit x tends to minus infinite, and again we'll get this same differentiation will be 2x plus e to the power x upon x square plus e to the power x into x to the power 4 plus e to the power 2x upon 4x cube plus 2 into e to the power 2x. Now here this is x and x4, x to the power 5. Here it is x square and x cube, x to the power 5. So we'll divide everything with x to the power 5. So we can write limit x tends to minus finite. This is 2 plus e to the power x upon x, and here it will be 1 plus e to the power 2x upon x to the power 4, and this is 1 plus e to the power x upon x square, and here will be this 4 plus 2 e to the power 2x upon x cube. Now e to the power nx upon x to the power r, where limit x tends to minus infinite, e to the power minus infinite is 0 and 0 upon infinite is 0. So all these terms they will be 0. So from here we'll get the value of m as also 1 by 2. So L is 1 by 2 and m is also 1 by 2. In this case, answer to this question will be L equals m, and that's your option A. Now the question is, we need to solve this limit x tends to 0 greatest in a function of 1 minus e to the power x sin x upon mod x. Now since this question has both greatest integer and mod with change definition at 0, we have to use left hand limit and right hand limit. So first we'll write its left hand limit. So its left hand limit will be limit x tends to 0 negative 1 minus e to the power x sin x upon mod x. Now we let x as 0 minus h, so it will be this limit h tends to 0 positive, and it will be 1 minus e to the power minus h, and here it will be this sign minus h upon mod of minus h, which we can write as get a function of 1 minus e to the power minus h into minus sin h upon h. Now we know that if h tends to 0 positive, then e to the power minus h, it lies between 0 and 1. Then 1 minus e to the power minus h will be greater than 0 but less than 1. In the same way, we know that if h is positive, then h is nearly 0, then sin h is less than h, that will be greater than 0, or we can say sin h upon h will lie between 0 and 1. And we multiply it with minus, then we can write value of sin h upon h will lie between minus 1 and 0. So one of them is positive and one of them is negative. So their product negative, and both of them the value lies between 0 and 1. So value of this product 1 minus e to the power minus h into sin h upon h will lie between minus 1 and 0. And if this value lies between minus 1 and 0, then its greatest new function will be minus 1. So its left hand limit is minus 1. Now we'll come to its right hand limit. Now for its right hand limit, we'll write limit h tends to 0 positive, and then it will be greater function of 1 minus e to the power h, and here it will be this sin h upon h. Now in this case, e to the power h will be greater than 1. So 1 minus e to the power h will lie between minus 1 and 0, whereas sin h upon h will lie between 0 and 1. Now again this product 1 minus e to the power h into sin h upon h, it will lie between minus 1 and 0. So value of this greatest function again is minus 1. Now since left hand limit is minus 1 and right hand limit is minus 1, value of this limit is minus 1, and that's your option A. Now here the question is, we need to solve this limit n tends to infinite 1 into this summation k varies from 1 to n, plus 3 into summation k varies from 1 to n minus 1 up to 2n minus 1 into 1 upon n to the power 4. Now since this is infinite limit and the highest power of n in the denominator is 4, and since the answer is non-zero finite, highest power of n in the numerator must also be n to the power 4. So basically answer to this limit will be coefficient of n to the power 4 in this series, which is this summation r varies from 1 to n 2r minus 1, this summation k varies from 1 to n minus r plus 1 into k. So essentially we are looking for coefficient of n to the power 4 in this series. Now this is summation r varies from 1 to n 2r minus 1, and here it will be n minus r plus 1 n minus r plus 2 whole divided by 2. Now we can write this as summation r varies from 1 to n 2r minus 1, and here will be this r square minus r 2n plus 3 and plus n plus 1 into n plus 2 whole divided by 2. Now we can further expand it as this summation r varies from 1 to n, and there will be 2r cube minus 2r square into 2n plus 3 plus n plus 1 n plus 2 into 2r, and then it will be minus r square r 2n plus 3 and minus n plus 1 into n plus 2 whole divided by 2. So it will be this 1 by 2, and then this summation 2r cube where r varies from 1 to n, and then we have this r square here plus r square into minus 4n minus 6 minus 1. So there will be minus 7 plus n plus 1. There will be this summation r square n plus 1 n plus 2 into 2 into summation r 2n plus 3 into summation r minus summation n plus 1 into n plus 2. Now this is 1 by 2 and this is 2, and summation r cube is n n plus 1 by 2 whole square, and here it is minus 4n plus 7, and this is n plus 1 2n plus 1 by 6 plus this is n plus 1 n plus 2 into 2, and this is n plus 1 by 2 2n plus 3 n plus 1 by 2 and minus n plus 1 n plus 2 into n. Now here we are looking for coefficient of n to the power 4. Now in this case it will be this 2 into 1 by 2. So there will be this 1 by 2. Now here this coefficient will be 4 into 2, 8. 8 divided by 6. So there will be minus 4 by 3 and plus, here this 2 and 2 will cancel, plus 1. And there is no other term containing n to the power 4. Now this is 1 by 2. And then 1 by 2 minus 4 by 3 plus 1. So there will be minus 1 by 3. And there will be 1 by 6, which is 1 by 12. So answer to this limit is 1 by 12, and that is what we need to prove in this question. Now here the question is, we are given this function fx, and it is limit m tends to infinite, limit n tends to infinite, cos to the power 2 factorial n pi x to the power m. So we have actually rearranged it. Now we are taking two cases. Case 1, if x is rational. Now if x is rational, then x is of the form some p by q, where q is an integer, and when we multiply this factorial n with pi into x, which in this case is p by q, as n tends to infinite, this n will contain q at some place. So this q and q will cancel. So basically it will be an integral multiple of pi. And if it is an integral multiple of pi, then in that case cos factorial n pi p, it will take the value either plus 1 or minus 1. So in this case, when x is rational, this fx will simply be plus or minus 1 to the power 2m, which is 1. So when x is rational, the value of fx is 1. Now if x is irrational, in that case, this cos factorial n pi p, it cannot be plus or minus 1. That means the value of cos square factorial n pi x, it will lie between 0 and 1. And if this value lies between 0 and 1, then this limit m tends to infinite, cos square factorial n pi x to the power m will be 0, because we know that a to the power infinite is 0 if a lies between 0 and 1. So if it is rational, function takes the value 1, and if it is irrational, function is going to take the value 0. Now here the question is, we are given this determinant delta x, and we need to find the value of this limit h tends to 0 root 3 delta pi by 3 upon h square. Now if we look at this limit h tends to 0 root 3 upon h square delta pi by 3 will be this 10. We'll put x as pi by 3 later, so we'll write this as 10x plus h, 10x plus 2h, 10x plus 2h, 10x, 10x plus h, and here it is 10x plus h, 10x plus 2h, and 10x. Now what we'll do is we'll write C3 as C3 minus C2 and C2 as C2 minus C1. We can write this as this limit, say L, and it will be this limit h tends to 0. This is root 3, and here we have 10x, 10, x plus 2h, and 10 x plus h. Here will be 10 x plus h minus 10x. This is 10x minus 10 x plus 2h, and here will be 10 x plus 2h minus 10 x plus h. In the same way, here will be 10 x plus 2h minus 10 x plus h. This is 10 x plus h minus 10x, and here will be this 10x minus 10 x plus 2h. And then we have this h square, and what we'll do is we'll take 1 upon h in column 2 and 1 upon h in column 3. Now if you look at these limits, now this limit h tends to 0, 10 x plus h minus 10x upon h. This is 0 upon 0 form. If we differentiate this, we'll get this as secant square x. And the second limit h tends to 0, 10x minus 10 x plus 2h upon h, which again is 0 upon 0 form. If we differentiate this, we'll get this as minus 2 secant square x. And finally this third one, limit h tends to 0, 10 x plus 2h minus 10 x plus h upon h, and we differentiate and put h as 0, we'll get this as secant square x. So using these limits, we can write this limit L as root 3, and then it will be this 10x, here will be this secant square x, and here it is x plus 2h. When h tends to 0, it will again be 10x, and here will be minus 2 secant square x, and this is secant square x. Now this again is 10x, this is secant square x, and this is minus 2 secant square x. Now we'll take R3 as R3 minus R2 and R2 as R2 minus R1. So this limit will be root 3, and then this is 10x secant square x, and this is 10x minus x 0. This is minus 3 secant square x, and this is minus 3 secant square x, and here will be this 0 minus 3 secant square x, and it will be this 0. So if we expand it above this first column, we'll get this as root 3 into 10x into 9 secant to the power 4x. Now we need to find this limit when the value of x is pi by 3. So if we put x as pi by 3, this limit will be 9 root 3. Now 10 pi by 3 is root 3, and secant pi by 3 is 2. So there will be 2 to the power 4. So this limit will be 27 into 16, which is 432. Now here the question is, we are given two statements. If we look at the statement 2, and statement 2 is limit x tends to infinite, fractional part of x upon x, it is equal to 0. Now we know that any fractional part function will always lie between 0 and 1. Now if we divide everything with x, we can write fractional part of x upon x will be less than 1 by x. Now if we take this limit x tends to infinite, then limit of this function on the left hand side is 0, and limit of this function on the right hand side, which is 1 by infinite, is also 0. Then from sandwich theorem or squeeze play theorem, we can say that this limit x tends to infinite, fraction part of x upon x is equal to 0. That means this statement 2 is correct. Now if we look at this statement 1, then we are supposed to find this limit x tends to 0 positive x upon a and get a function of b by x. Now we can write this as limit x tends to 0 positive. This is x by a, and we can write b by x minus fractional part of b by x. Now we can write this as b upon a minus this limit x tends to 0, and we can rearrange this as 1 upon a b by x, and this is 1 by x. We'll multiply and divide with b also. Now when x tends to 0, 1 by x tends to infinite. Now this statement 2 says if x tends to infinite, then fractional part of x upon x, it is 0. So in that case, this limit will be 0. So value of this limit will be simply b by a. So this statement 1 is true, statement 2 is true, and statement 2 explains statement 1. Now the question is, we need to find this limit x tends to 0, x plus log under root of 1 plus x square minus x whole divided by x cube. Now for this question, what we'll do is we'll take this under root of 1 plus x square minus x as sum y. Now if we take this x on the right hand side and square it, we'll get 1 plus x square, and it will be y square plus x square plus 2xy. Now here x square will cancel. We can write x as 1 minus y square upon 2y. Now clearly, when x tends to 0, y tends to 1. So we can write this limit as limit y tends to 1, and here it will be x, which is 1 minus y square upon 2y plus log y upon x cube, which is 1 minus y square upon 2y whole cube. Now we can write this as limit y tends to 1, and this is 1 minus y square plus 2y log y, and here it will be 1 minus y square whole cube into 2y whole square. Now we can write 1 minus y square is 1 plus y and 1 minus y. So we write this as limit y tends to 1, 1 minus y square plus 2y log y upon 1 minus y cube and 1 plus y cube, and here will be this 2y square. Now we don't have a problem with this because here it is 2, which is 4, and here it is 2 cube. So it will be 1 by 2, and this is 0.0 form. So we can write this as limit y tends to 1, 1 by 2 into 1 minus y square plus 2y log y upon 1 minus y whole cube. Now for this, what we'll do is we'll let 1 minus y as h. So it will be this limit h tends to 0, and this is 1 minus h whole square plus 2 1 minus h into log 1 minus h upon h cube. Now this is limit h tends to 0. Now here 1 and 1 will cancel, so we'll get this as 2h minus h square plus 2 into 1 minus h, and we'll use expansion for log 1 minus h. So it will be this minus h square upon 2 minus h cube upon 3 upon h cube. Now we simplify this, we can write this as limit h tends to 0 will be 2h minus h square, and there will be minus 2h plus 2h square, and then minus h square plus h cube, and then minus 2 by 3 h cube plus higher powers of h divided by h cube. Now 2h will cancel, h square will also cancel. Now minimum power in the numerator and minimum power in the denominator is both 3, and we also have this 1 by 2 which I forgot. So it should be this 1 by 2, 1 by 2 and 1 by 2. So answer to this limit will be 1 by 2 and then coefficient of h cube in the numerator, which is 1 by 3, and the denominator it is 1. So answer to this limit is 1 by 6. Now here the question is, we need to find this limit n tends to infinite r cube minus 8 upon r cube plus 8. So we write this as limit n tends to infinite, this product r varies from 3 to n, and this is r minus 2 r square plus 2r plus 4 upon r plus 2 r square minus 2r and plus 4. Now we'll separate it in two products. So it will be this limit n tends to infinite r minus 2 upon r plus 2, this product where r varies from 3 to n, and then this limit n tends to infinite r square plus 2r plus 4 upon r square minus 2r plus 4. Now if we look at this, there is a difference of 4, and for this one we can write this as r plus 1 whole square plus 3 and r minus 1 whole square plus 3. So here it's a difference of 2. So terms will cancel after 4, and here terms will cancel after 2. So we can write this as this limit n tends to infinite. Now if we put r as 3, it will be 1 by 5. Now this is 2 by 6, 3 by 7, 4 by 8, 5 by 9, and it will go all the way up to n minus 2. Here terms will cancel after 4. So here we'll have 4 terms. So it will be this n plus 2, n plus 1, n and n minus 1. So we'll have these 4 terms. Now into, and for this one, if we put r as 3, it will be 4 square plus 3 upon 2 square plus 3, and then it will be 5 square plus 3 upon 3 square plus 3, and now it will be 6 square plus 3 upon 4 square plus 3. So these terms, they will start getting cancelled now. So in the end, we'll have n square plus 3 and n plus 1 whole square plus 3, and all those terms will cancel. So we'll get this as limit n tends to infinite. Now this is 24 upon, this is n square minus 1, n plus 2, and here it is n square plus 3 and n square plus 2n plus 4. And we also have 4 and 3 is 7, and this is 9 plus 3 12. Now here coefficient of n to the power 4 is 24, and here coefficient of n to the power 4 is 24. So this value will be 2 by 7. So answer to this limit is simply 2 by 7. Now here the question is, we need to find the value of this limit x tends to pi by 4 to 1 plus greatest integer function of x to the power 1 upon log 10x. Now in this case we must know that when x approaches pi by 4, greatest function of x, it is 0. Now this greatest integer function, it takes exact value. It cannot take limiting value. So this form, it is not of the form 1 to the power infinite. So this limit is just going to be 1, and that's your option B. Now here the question is, we need to find the value of this limit, which is y, and limit n tends to infinite factorial n upon n to the power n to the power 3n cube plus 4 upon 4 n to the power 4 minus 1. Now what we'll do is, we'll write this as limit n tends to infinite, and we'll write it in terms of this product that r varies from 0 to n minus 1 n minus r upon n whole to the power, and here also we'll multiply and divide it with n. So it will be 3 n to the power 4 plus 4n upon 4 n to the power 4 minus 1 into 1 by n. Now what we'll do is, we'll take log both sides. So we'll write log y, and it will be equal to limit n tends to infinite 3 n to the power 4 plus 4n upon 4 n to the power 4 minus 1, and then into this 1 by n summation 1 minus r by n, where r varies from 0 to n minus 1. So we have this form. Now this is infinite limit. Highest power is n to the power 4. So this limit is going to be 3 by 4. So we can write this as log y equals 3 by 4, and then into this limit n tends to infinite 1 by n, this summation r varies from 0 to n minus 1, 1 minus r by n. Now here we'll take x as r by n, and this is nothing but this is limit of sum. N tends to infinite, we have 1 by n, and then we have this variable r by n. So it will be this log y equals 3 by 4, and we'll change it in integral form. Here will be this log 1 minus x dx, and then this limit from 0 to 1, which is also same as 3 by 4 0 to a minus x. So we can write this as log x dx. Now it will be this log y 3 by 4, and this is x log x minus x from 0 to 1. Now this is 3 by 4. Now log 1 is 0 minus this limit x tends to 0 x log x, and then minus 1. Now this is 0 into infinite limit, so we can write this as limit x tends to 0 log x upon 1 by x, which is 1 by x upon 1 by x square. So this limit is 0. So from here we can write log y equals minus 3 by 4, or value of y is e to the power minus 3 by 4. So value of this limit is e to the power minus 3 by 4. And that's your option A. Now here the question is, we need to find the value of this limit n tends to infinite cos square pi, and this is n cube plus n square plus 2n to the power 1 by 3. Now we'll take n cube common, so it will be this limit n tends to infinite cos square n pi, and here it will be 1 plus 1 by n plus 2 by n square to the power 1 by 3. Now what we'll do is, we'll use binomial expansion. So we'll write this as limit n tends to infinite cos square n pi, and here it will be 1 plus 1 by 3n plus 2 by 3n square plus higher power of 1 by n. Now we'll write this as limit n tends to infinite. Now this is cos square and n pi plus pi by 3 plus 2 pi by 3n. Now cos n pi plus theta is minus 1 to the power n cos theta. So it will be this limit n tends to infinite minus 1 square to the power n, and then cos square pi by 3 plus 2 pi by 3n. Now minus 1 square is plus 1, and if we take n tends to infinite, all these terms they will be 0. So this answer will be simply cos square pi by 3, and cos square pi by 3 is 1 by 4. And that's your option C. Now here the question is, we are given this function fx, which is x plus 3 when x lies between minus 2 and 0, 4 when x is equal to 0, and 2x plus 5 when x lies between 0 and 1. Now first question is, we need to find this limit x tends to 0 negative f greatest is a function of x minus 10x. Now if we look at graph of y equals x and y equals 10x, then when x is negative, then in that case x is greater than 10x. That means x minus 10x is greater than 0. But this value, it lies between 0 and 1. Therefore, its greatest needed function x minus 10x will take the value 0. So this limit will be equal to f0, and f0 is 4. That means the correct option is this option B. Now the next one is limit x tends to 0 positive f fractional part of x upon 10x. Now we know that when x is positive, then x is less than 10x, or x upon 10x, it is less than 1. Now when h lies between 0 and 1, then fractional part of h is same as h. So that means this limit, it will be simply limit x tends to 0 positive f x by 10x. Now x by 10x is actually less than 1, and if it is less than 1, it will go to this definition. So we can write this as limit x tends to 0 positive 2 times x upon 10x plus 5, which is 7. So answer to the second part is 7, and that's your option C. Now the question is, if limit x tends to 0 fx upon sin square x equals 8. Now it has to be 0 upon 0 form. That means f0 is 0, and also this limit x tends to 0 gx upon 2 cos x minus x into e to the power x plus x cube plus x minus 2. Now if you put x is 0, so it is 2 minus 2 0, 1 minus 1 0, so which again is 0 upon 0 form. This is lambda, and we also know g0 is equal to 0, and we are given that this limit x tends to 0 1 plus 2 fx to the power 1 upon gx, it is e to the power minus 1. Now this is 1 to the power infinite form. If we use shortcut, we can write this as e to the power limit x tends to 0 2fx upon gx, it is equal to e to the power minus 1. So from here we can write this limit x tends to 0, fx upon gx, this value will be minus 1 by 2. Now we need to find the value of lambda. Now what we'll do is, we'll divide these two limits. Now if we divide them, we can write limit x tends to 0, fx upon gx into 2 cos x minus x into e to the power x plus x cube plus x minus 2 upon sine square x, and it will be equal to 8 upon lambda. Now we have already worked this out. This is minus 1 by 2, so it will be this minus 1 by 2 and then this limit x tends to 0. Now we write this as minus 2 1 minus cos x minus x into e to the power x minus 1 plus x cube upon sine square x, and it is equal to 8 upon lambda. What we'll do is, we'll divide numerator and denominator with x square. So this is x square, this is x square upon x square. Now this is minus 1 by 2. Now 1 minus cos x upon x square is 1 by 2. So this is minus 1. Here e to the power x minus 1 upon x is 1. X will cancel. So this is minus 1 plus 0 upon this is 1. That is equal to 8 upon lambda. So clearly value of lambda is 8. And that is the answer to this question. Now we look at the second limit. The second limit is limit x tends to minus infinite under root of x square minus x plus 1 minus ax minus b, and it must be equal to 0. Now first we'll check its form. Now this is infinity and then minus a into minus infinite. Now if a is greater than 0, in that case this limit will be infinite, which is non-indeterminate form. So for this limit to have an answer 0, clearly a must be less than 0. So we are looking for the value of a, which is negative. Now we can write this as limit x tends to minus infinite. Now we'll rationalize it. So we'll write this as x square minus x plus 1 minus ax plus b whole square whole divided by under root of x square minus x plus 1 and plus ax plus b, and it should be equal to 0. Now we write this as limit x tends to minus infinite, and here will be this 1 minus a square x square and then plus minus 1 minus 2abx and plus 1 minus b square upon under root of x square minus x plus 1 plus ax plus b, and it must be equal to 0. Now in the denominator, highest power is 1. So in the numerator also, highest power should be 1 or less for this limit to be 0. That means coefficient of x square, it should be 0. From here we'll get the value of a as either plus 1 or minus 1. But we already know that a cannot be positive. So the only value of a possible in this case is a equals minus 1. Now once there is no x square, then answer to this limit will be coefficient of x. Now coefficient of x in the numerator will be minus 1 minus 2ab upon, now here if we take x square common, then it will be this mod x 1 minus 1 upon x, and this mod x is minus 1, so it will be this minus 1 plus a, and it must be 0. Though in this question this minus doesn't make a difference, but then most of the people, they make a mistake when they're going to write this coefficient of x in the denominator. Now from here we can write 2ab, it is equal to minus 1. Then value of b is equal to 1 by 2. So for the second one, a is minus 1 and b is 1 by 2. Now here the question is, we need to find this limit when x tends to 0. So this is L and LB. This limit x tends to 0, sin x to the power 1 by x, and plus this limit x tends to 0, 1 by x to the power sin x. Now this is 0 to the power infinite form, and this is infinity to the power 0 form. Now basically 0 to the power infinite is not an indeterminate form. So we'll actually write this as e to the power limit x tends to 0 log sin x upon x, and plus this limit x tends to 0 e to the power limit x tends to 0 sin x, and this is log 1 by x. Now first we'll check its form. So this is log 0 is minus infinite, and minus infinite upon 0 is actually minus infinite. So this is e to the power minus infinite, and e to the power minus infinite is 0. So value of this first limit is 0. That means this L is simply the second limit, which is limit x tends to 0, and this is e to the power limit x tends to 0. We'll write this as minus log x upon cosec x, which is infinity upon infinity form. Now we use L'Hopital's rule, so it will be this e to the power limit x tends to 0, and this is minus 1 by x, and this is minus cosec x into cot x. Minus and minus will cancel, so it will be this e to the power limit x tends to 0 sin x into tan x upon x. Sin x upon x is 1 and tan x is 0. So it will be this e to the power 0. That means value of this limit is simply 1. And that's your option C. Now here the question is, if e denote the base of natural logarithm, then the value of real number a for which the right hand limit x tends to 0 positive 1 minus x to the power 1 by x minus e to the power minus 1 upon x to the power a is equal to a non-zero real number. Now we'll solve this question using expansion. So we use the expansion of 1 minus x to the power 1 by x. Now one of the way to find this expansion is using Maclaurin series, which we have covered in one of the previous videos. Now since we are assuming it's for JEE, we are not going to use Maclaurin series in this case. So what I'll do is I'll say, suppose this expansion is y, and we can write this as e to the power log 1 minus x to the power 1 by x, which is e to the power 1 by x log 1 minus x. Now we'll use the expansion of log 1 minus x. So it will be this e to the power 1 by x, and it is minus x square upon 2 minus x cube upon 3, so on and so forth. So it will be this e to the power minus 1 minus 1 by 2 x minus x square by 3. Now we'll take e to the power minus 1 common. We can write this as e to the power minus x by 2 minus x square by 3 up to infinite. Now this is expansion of e to the power minus x, and we know that expansion of e to the power minus x is 1 minus x, and x in this case is x by 2 plus x square by 3 and plus x square upon factorial 2. Now we are just concerned with first few powers. So in this case, if I take square of the series, then the term I'll get is x square upon, now this is 4 and 2, it will be this 8. So we'll get this as e to the power minus 1 minus x by 2, and then it'll be this minus x square by 3 plus x square by 8. So it'll be this minus 5x square by 24. Now we use this expansion to solve this limit. Now we put this expansion in this limit. We can write this limit as limit x tends to 0 positive, and here it will be e to the power minus 1, 1 minus x by 2 minus 5x square by 24, and then minus e to the power minus 1 upon x to the power a. Now e to the power minus 1 will be cancelled. Now minimum power of x in the numerator is 1. So this limit will have a non-zero real number answer if the minimum power in the denominator is also 1. That means value of a must be 1 in this case. So the value of real number a, it must be 1. And if it is 1, then answer to this limit will be minus 1 upon 2e. Now the question is, find the possible value of k for which this limit is equal to 1 by 2. Now what we'll do is we'll divide everything with x cubed. So we can write limit x tends to infinite 2 minus tan inverse x upon x whole cube, and here it will be 8 upon pi cot inverse mod kx plus k square. Now will be sine 1 by x cube, and here we have x cube, which we are going to write as 1 by x cube, and here it is minus 3k, and it is equal to 1 by 2. Now we'll take this limit x tends to infinite. Now this is 2 minus, now tan inverse infinite is pi by 2, and pi by 2 upon infinite is 0. Here this is cot inverse infinite. Now cot inverse infinite is 0. So this is 0. Here sine x upon x, when 1 upon x cube tends to 0, it is 1. So it will be this k square minus 3k, that is equal to 1 by 2. So from here we can write k square minus 3k minus 4 equals 0. So it will be this k minus 4 into k plus 1 equals 0. So value of k is either minus 1 or value of k is 4. That means the possible values are minus 1 and 4. Options B and D. Now we have this case when we have assumed that this k is unequal to 0, because this expression cot inverse kx will make a difference whether k is 0 or non-zero. So we have to consider one more case considering k equals 0. Now if k is 0, we'll have cot inverse 0, and cot inverse 0 will be pi by 2. In that case, we'll have this limit x tends to infinite 2 minus 0. Now this is 8 upon pi into pi by 2. There will be 4 plus k square minus 3k, and if k is 0, this value is again going to be 1 by 2. So that means one more value of k is possible. So there are 3 values possible for k, which are 0, minus 1 and plus 4. Now here the question is, we are given this function fx, which is this summation r varies from 1 to n r square x square plus x plus r upon r x square plus 1, its greatest linear function. Now we can write this as this summation r varies from 1 to n, and we'll take these two terms together. We'll take r common. It will be r x square plus 1 upon r x square plus 1 and plus x upon r x square plus 1. Now here r x square plus 1 will cancel, and since r is an integer, we can simply write this as this summation r varies from 1 to n summation r plus this summation r varies from 1 to n greatest linear function of x upon Rx square plus 1. Now summation R is n plus 1 by 2, and then we have to simplify this summation. R varies from 1 to n, greatest linear function of x upon R x square plus 1. Now this function is defined from 0 to infinite to n. That means value of x is positive. So what we'll do is we'll write x upon Rx square plus 1 as 1 upon Rx plus 1 by x, and if we take AMGN, then Rx plus 1 by x by 2, it is greater than or equal to under root R, or Rx plus 1 by x is always greater than or equal to 2 root R. Now if we take its reciprocal, then we can write x upon Rx square plus 1 will always be less than 1 upon 2 root R. That means it is always less than or equal to 1 by 2. Now if it is always less than or equal to 1 by 2, then the value of this greatest linear function will be 0. So basically this function fn, it is nothing but n into n plus 1 by 2. Now we need to find this limit, which is limit n tends to infinite, greatest linear function of fx minus n upon fx square minus n cube n plus 2 upon 4, its greatest linear function. Now we are going to write this as limit n tends to infinite, and this is greater function of, we'll take this n common, and here will be n plus 1 by 2 minus 1, and here it will be n square n plus 1 whole square by 4 minus n cube n plus 2 by 4. Now this is limit n tends to infinite, and here it will be n into n minus 1 by 2, and here we'll take n square by 4 common, then we'll have n plus 1 whole square minus n into n plus 2. Now this is limit n tends to infinite, and this is n minus 1 by 2, and here it is n square by 4. Now here n square plus 2n will cancel, so this value will be simply 1. Now this n and n will cancel, this 2 and 4 will cancel twice, so we can write this as limit n tends to infinite to n minus 1 upon n. Now this is limit n tends to infinite, and this is 2 minus 2 by n. Now if we consider this bracket as greatest integral function, then we know that 2 minus 2 by n is less than 2. In that case, value of this limit, it will be 1. And if we consider them as simple square brackets, then this limit will be simply 2 minus 0, and then it will be 2. In some of the books, you'll find this answer as L equals 2. But in the question, since they have mentioned that this box, it represents greatest linear function, so I think answer to this question should be L equals 1. Now here the question is, let f be a positive increasing function with limits x tends to infinite f3x upon fx equals 1. We need to find this limit x tends to infinite f2x upon fx. Now since fx is positive increasing function, then we know that fx will be less than f2x and will be less than f3x. Now we divide everything with fx. We can write 1 is less than f2x upon fx and will be less than f3x upon fx. Now if we take this limit x tends to infinite, this is 1, and in the question it is given that this limit is also 1. Then from sandwich theorem we can say that this limit x tends to infinite f2x upon fx will also be 1, and that's your option 4. Now question number 9 is, consider all non-empty subsets of the set 1, 2 up to n. For every such subset, we find the product of reciprocals of each of its element. Denote the sum of all these products as Sn. For example, S3 is 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 1 into 2 plus 1 into 3, 2 into 3, and then 1 into 2 into 3. Now we can write this S3 as 1 plus 1 upon 1, 1 plus 1 upon 2, 1 plus 1 upon 3, and then minus 1. Now this product, it has all these elements. So we can find sum of all these products Sn as 1 plus 1 upon 1 into 1 plus 1 by 2, 1 plus 1 by 3 up to 1 plus 1 by n minus 1. Now we can also write Sn minus 1 as 1 plus 1 upon 1, 1 plus 1 by 2 up to 1 plus 1 by n minus 1 minus n. Now if in this product we consider all these terms up to 1 plus 1 by n minus 1, then it will be equal to Sn minus 1 plus 1. So we can write this Sn as Sn minus 1 plus 1 into 1 plus 1 by n minus 1. Now if we multiply it, we can write 1 plus 1 by n Sn minus 1 plus 1 plus 1 by n minus 1. Now this 1 and 1 will cancel. So from here we can say this Sn will be equal to 1 by n plus 1 plus 1 by n into Sn minus 1, which is what we need to prove in part A. Now part B is hence or otherwise deduce that Sn it is equal to n. Now again if we consider this Sn, it is 1 plus 1 upon 1. Next is 2 plus 1 upon 2, 3 plus 1 upon 3, and it will go all the way up to n plus 1 upon n minus 1. Now this is 1, 2, 2, 3, 3, 4, and it goes all the way up to n plus 1 minus 1. Now this 2 will cancel, 3 will cancel, all these terms they will cancel. We'll get this Sn as n plus 1 minus 1. This 1 and 1 will cancel. So we can write Sn it is equal to n, which is what we need to prove in this second part. Question number 16 is, consider real valued function f satisfying fx plus 1 equals fx for all x belongs to R. That means this function is periodic with period 1. We are given that gt is this integral from 0 to t fx dx, and we have defined this function ht as this limit n tends to infinite g t plus n upon n. Now if we look at gt plus n will be nothing but 0 to t plus n fx dx. Now we can write this as this integral from 0 to n fx dx plus n to n plus t fx dx. Now this function is periodic with period 1. So we can write this as n into this integral from 0 to 1 fx dx and then plus, now this is from nt to
nt plus a, and it will be from 0 to t fx dx. So we can write this function h as this limit n tends to infinite n, this integral from 0 to 1 fx dx plus this integral from 0 to t fx dx upon n. Now we split it in two parts. This n and n will cancel, and 1 upon infinite will be 0. So this ht will be nothing but will be this value from 0 to 1 fx dx, which is a constant function. So this ht, it is defined for all t belongs to R, and it is independent of t, and that's here option C.
Now question number 23 is, we need to find this limit n tends to infinite fractional part of 3 plus 2 root 2 to the power n. Now what we'll do is, we'll say, suppose its integral part is R and fractional part is f, we can write this as 3 plus 2 root 2 to the power n. Now this is nc0 3 to the power n plus nc1 3 to the power n minus 1 2 root 2 and so on, and then we'll consider this f, which is 3 minus 2 root 2 to the power n. It lies between 0 and 1. This capital F, it lies between 0 and 1, and here also any fractional part, it lies between 0 and 1. Now if we add them, we can write R plus f will be 2 times 3 to the power n plus nc2 3 to the power n minus 2 into 2 root 2 square. Now this right hand side, it is integer. This R, it is also an integer. That means this f plus f, it must also be an integer. Now if we add capital F plus small f, it lies between 0 and 2, and the only integral value possible in this case is 1. So we can write this small f as 1 minus capital F, or fractional part of 3 plus 2 root 2 to the power n will be 1 minus 3 minus 2 root 2 to the power n. Now we'll take this limit n tends to infinite. Limit n tends to infinite. And this is 1, and this value, it lies between 0 and 1. So a to the power infinite in this case will be simply 0. So answer to this limit is 1, and that's your option B.
Now question number 14 is, let Vn be a sequence defined by V1, which is 1, and then Vn plus 1 equals under root of Vn square plus 1 upon 5 to the power n. Then we need to find this limit n tends to infinite Vn. Now we can write Vn plus 1 square minus Vn square as 1 upon 5 to the power n. Now we'll put n as 1, we'll get V2 square minus V1 square, it is 1 by 5. If we'll put n as 2, we'll get V3 square minus V2 square will be 1 upon 5 square, and then we can write Vn square minus Vn minus 1 square will be 1 upon 5 to the power n minus 1. Now we'll add them. Now we'll add them, all these terms they'll cancel. From here we can write Vn square minus V1 square, and will be 1 by 5 plus 1 upon 5 square plus 1 upon 5 to the power n minus 1. So we can write Vn square as, now V1 is 1, 1 plus 1 by 5, 1 by 5 square, 1 upon 5 to the power n minus 1. Now we need to find this limit, limit n tends to infinite Vn. So we'll find limit n tends to infinite Vn square, it is nothing but, it is this infinite GP. So we know that sum of infinite GP is a upon 1 minus r. So from here we can write Vn square limit n tends to infinite, it will be 1 upon 1 minus 1 by 5, which is 5 by 4. So this limit n tends to infinite Vn will be simply root 5 by 4, And that's your option number B. Question number 8B is, we are given a sequence in which A0 is 1 and A1 is 1. And for n from 1, 2, 3, 4, it defines an plus 1 as 1 plus an minus 1 square by 4. Now the question is, does the sequence an converge to a finite limit as n tends to infinite? And if it does, we need to find this limit. In the first part, we'll prove that this an plus 1, it is bounded. So we'll show that an plus 1 will lie between 0 and 1, and we'll prove this by induction. So our statement is, for any n greater than or equal to 1, an plus 1, it is greater than 0 but less than 1. Now we'll put P1. Now P1 is actually A2. Now what's A2? A2 is 1 plus A1. A1 is 1. A0 square. A0 is also 1. So divide by 4. So it is 3 by 4. So value of A2 lies between 0 and 1. Now we'll assume that it'll be true for any value of k starting from 1 to n. So we can write ak minus 1 will lie between 0 and 1, and ak will also lie between 0 and 1. Now we'll need to prove that this statement is true for k plus 1. So for k plus 1, we can write ak plus 1 as 1 plus ak minus 1 square upon 4. Now we know that ak lies between 0 and 1. ak minus 1 also lies between 0 and 1. Now we'll square it. We'll write 0 and then ak minus square will also lie between 0 and 1. So we'll add them. We can write 0 and ak plus ak minus 1 square will lie between 0 and 2. Now we'll add 1. So we'll add 1. We can write 1 is less than 1 plus ak minus 1 square, and it is less than 3. Now we'll divide it with 4. This is nothing but ak plus 1. So from here we can say this ak plus 1 will be greater than 0 but less than 1. So from induction we have proved that any term for the sequence will always lie between 0 and 1. Now we'll need to find the limiting value of the sequence. So what we'll do is, here we'll take limit n tends to infinite. So it'll be limit n tends to infinite, and it'll be equal to this limit n tends to infinite 1 plus an minus 1 square upon 4. Now suppose this limit exists and it is equal to L. So this is L and here it will be 1 plus. Now again when n tends to infinite, this is limiting value of the sequence. So it will be again L and here it will be L square by 4. So from here we'll get this condition, which is L square minus 3L plus 1 equals 0. Now it is a quadratic equation in L. So we'll solve this equation. We'll get L as 3 plus minus under root of 9 minus 4 by 2. So limiting value of the sequence will be 3 plus minus under root 5 by 2. Now in the first part we have already proved that this ak plus 1 should be less than 1. So the only value possible in this case is 3 minus root 5 by 2. So the sequence, it converges to a finite limit, and that finite limit is 3 minus under root 5 by 2, and that is the answer to this question. Now question number 18, it says let Pn be number of digits when 8 to the power n is written in base 6, and let Qn be number of digits when 6 to the power n is written in base 4. We need to find this limit, which is limit n tends to infinite Pn Qn upon n square. Now there is a direct formula for that. So if we write 8 to the power n to the base of 6, then number of digits Pn, it is given by greatest integer function of log 8 to the power n to the base 6 and then plus 1. So this is the formula to find out number of digits in other base. So in the same way, we can find number of digits Qn when the base is 4. So Qn will be log base is 4 and number here is 6 to the power n and plus 1. So basically Pn is n log 8 base 6 plus 1 and Qn is greatest integer n log 6 base 4 plus 1. Now we need to find this limit, which is limit n tends to infinite Pn into Qn upon n square. Now in greatest integer function, we know this property that greatest integer function of x is always less than or equal to x, and it is greater than x minus 1. So I can write Pn is less than or equal to n log 8 base 6 plus 1, and it is greater than n log 8 base 6. In the same way, we can write Qn. So Qn will be less than n log 6 base 4 plus 1, and here will be n log 6 base 4. Now if we multiply them, then we can write it as n square log 8 base 6 into log 6 base 4 is less than Pn into Qn, and it is less than n log 8 base 6 plus 1 into n log 6 base 4 plus 1. So now I'll need to find this limit. So I'll need to divide it with n square. So I'll also divide it with n square. So if I'll divide it with n square, and I'll take this limit also. I'll take this limit n tends to infinite. Now since it is an infinite limit, so highest power of n in the numerator and denominator is 2. So answer to this left hand limit will be simply log 8 into log 6, and here it is limit n tends to infinite Pn Qn by n square, and here also the highest power is n square. So here also this limit will be log 8 base 6 into log 6 base 4. Now Sandwich theorem says if fx lies between gx and hx, and if limiting value of gx is L and limiting value of hx is L, then the limiting value of this limit is also L. So which simply means the value of this limit is equal to log 8 base 6 into log 6 base 4. So I can write it as log 2 base 8 upon log 6 base 2, and here will be log 6 base 2 upon log 4 base 2. So it will cancel. So 8 is 2 cube and 4 is 2 square. So the value of this limit is simply 3 by 2, and that's your option number C. Now question number 20 is this function from R to R be a non-zero function such that this limit x tends to infinite fxy upon x cube exists for all y greater than 0. Let gy equals this limit x tends to infinite fxy upon x cube. Now it is given that g1 is 1. So we'll put y as 1. We can write limit x tends to infinite fx upon x cube, it is equal to 1. Now we need to find gy. Now what we'll do is we'll write this gy as this limit x tends to infinite fxy, and here we'll write this as xy cube into y cube. Now we can write this gy as y cube into limit x tends to infinite fxy upon xy cube. Now when x tends to infinite, xy also tends to infinite. So this limit, its value is 1. So we can write this function gy, it must be this function y cube, and that's your option D. Now question number 30 is we are given this function from 0 to 1 to minus 1 to 1, and it will be a non-zero function such that f2x is equal to 3fx when x lies between 0 and 1 by 2. We need to find this limit x tends to 0 positive fx. Now what we'll do is we can write this fx as 1 by 3 f2x. Now we can write f2x as 1 upon 3 square into f 2 square x, and if we continue the iteration, we can write this as 1 upon 3 to the power n f 2 to the power of n into x. Now we can keep doing it till we get this limit n tends to infinite. So we can write this function fx as this limit n tends to infinite f 2 to the power of n into x upon 3 to the power of n. Now we need to find this limit x tends to 0 positive fx, and it'll be equal to this limit x tends to 0 positive limit n tends to infinite f 2 to the power nx upon 3 to the power n. Now range of this function is from -1 to 1. So this value in the numerator will lie somewhere between -1 and +1, which is a finite value, upon 3 to the power infinite, which is infinite. So value of this limit is 0. So value of this limit x tends to 0 fx is equal to 0, and that's your option D. Now let us take one question in limits, and this problem was asked by one of my students. It says let fx equals 8x cubed plus 3x and f inverse be the inverse of fx. Then we have to find this limit x tends to infinite x to the power 1 by 3 upon f inverse 8x minus f inverse of x. Now what we are given is, we are given fx is 8x cubed plus 3x. Now we find f dash x will be 24x square plus 3, and it is always greater than 0. So that means this function fx, it is strictly increasing. And if we find f double dash x, it will be simply 48x. That means its point of inflection is at x equals 0. So this function, it will be strictly increasing function which will intersect the axis only at x equals 0. Now we have to solve this limit, which is limit x tends to infinite x to the power 1 by 3 upon f inverse of 8x minus f inverse of x. Now what we'll do is, we'll say let f inverse of 8x is z and let f inverse of x be some y. We'll write let f inverse of 8x equals z and f inverse of x as y. Now we can write f inverse of 8x equals z as 8x equals fz. Now what's fz? Fz will be 8z cube plus 3z. So we can write this as 8x equals 8z cube plus 3z. Now what we'll do is, we'll take 8z cube common. So we'll write 8x equals 8z cube 1 plus 3 by 8 z square. Now we'll cancel this 8 with 8 and we'll take cube root both sides. We can write x to the power 1 by 3 equals z 1 plus 3 upon 8 z square to the power 1 by 3, or we can express z as x to the power 1 by 3 upon 1 plus 3 by 8 z square to the power 1 by 3. Now in the same way, we can solve this other condition, which is fx equals y. We can write x equals fy. Now fy is 8y cube plus 3y. Again we'll take 8y cube common. We'll write 1 plus 3 by 8 y square. And if we take cube root again, we'll get x to the power 1 by 3 and it'll be equal to 2y 1 plus 3 by 8 y square to the power 1 by 3, or we can write y as x to the power 1 by 3 upon 2 1 plus 3 by 8 y square to the power 1 by 3. Now what we'll do is, we'll put the value of z and y in this limit. Now we can write this limit as limit x tends to infinite x to the power 1 by 3 upon z minus y. Now z in this case is x to the power 1 by 3 upon 1 plus 3 by 8z square to the power 1 by 3 minus x to the power 1 by 3 upon 2 1 plus 3 by 8y square to the power 1 by 3. Now we can cancel this x to the power 1 by 3 from the numerator and from the denominator. Now we have to find the value of this limit z and y when x tends to infinite. Now z is f inverse of 8x and y is f inverse of x. Now this function fx, it is an increasing function. So as x tends to infinite, fx tends to infinite. And if we talk about inverse function, its inverse function is nothing but it is reflection of fx about y equals x line. Now for inverse function also, when x approaches infinite, f inverse will also approach infinite. So it simply means that when x tends to infinite, z tends to infinite and y tends to infinite. And if z and y, they both approach infinity, then in that case 3 by 8z square will be 0 and 3 by 8y square will also be 0. So value of this limit in this case will be 1 upon 1 by 1 minus 1 by 2, which is nothing but 2. So answer to this limit is 2. And that's your option C. Now the question is, let A is nth power of this matrix 2, 1, 1, 0. And we need to find this limit n tends to infinite a1, 2 upon a2, 2. Now let this matrix be B, and which is 2, 1, 1, 0. And we'll write this as this 1, 0, 0, 1 plus 1, 1, 1 minus 1. So this is I and this is suppose C. So we can write this B as I plus C. So now we have this matrix C, which is 1, 1, 1 minus 1. Now we find C square will be 1, 1, 1 minus 1 and then 1, 1, 1 minus 1. Now we multiply. We'll get this as 2. Now this is 0. This is 0. And then it'll be 2. So C square is basically 2i. So once we have this expression, then we know that C square will be equal to 2i. And if we multiply it with C, we'll get C cube as 2c. Now we multiply it again with C, we'll get C to the power 4 as 2c square, and 2c square is 2i. So there'll be 4i. C to the power 5, there'll be again 4c, and this sequence will continue like that. Now we have assumed this B is I plus C. Now we take nth power of B, then it will be I plus C to the power n. Now we can write this as B to the power n equals nc0 into I plus nc1 into C nc2 into C square nc3 into C cube, and this series will continue up to ncn into C to the power n. Now for even powers of C, it will be simply 2i, nc4 will be nc4 into 4i. So we can write this as nc0 plus 2 into nc2 plus 4 into nc4 into I, and then plus, now this is C. Now C cube is 2c, C to the power 5 is 4c. So we can write this as nc1 plus 2 into nc3 plus 4 into nc5, and it will be multiplied with C. Now we need to find sum of these two series. So this is our first series and this is our second series. Now say this is P and this is Q. Now we consider the expansion of 1 plus root 2 to the power n will be nc0 plus nc1 into root 2 nc2 into root 2 square nc3 into 2 root 2. Now if we consider these terms, this is nothing but p, so it will be this p, and then if we take root 2 common, then it will be q. So we can write this as p plus root 2q. So value of p plus root 2q will be simply 1 plus root 2 to the power n. And if we take 1 minus root 2, it will be alternate plus minus. Then we'll get p minus root 2q, and there will be 1 minus root 2 to the power n. Now if we add them, we'll get the value of p. So we'll get this p as 1 by 2 into 1 plus root 2 to the power n plus 1 minus root 2 to the power n, and if we subtract them, we'll get this q as 1 upon 2 root 2, and then it'll be 1 plus root 2 to the power n minus 1 minus root 2 to the power n. So now we have worked out values of p and q. So basically we can write a, which is b to the power n, and there will be pi plus qc. So this a will be this pi, so it will be p0, 0 and p plus q into c. Now c was 1, 1, 1 minus 1. So there will be q, q, qn minus q. So this a will be p plus q, and this is q, this is q, and this is p minus q. Now it says we need to find this limit n tends to infinite a12. Now a12 is first row second column, which is this q, upon a22, and a22 is p minus q, and it's given that this is equal to L. Now this is limit n tends to infinite. Now q is 1 upon 2 root 2, and this is 1 plus root 2 to the power n minus 1 minus root 2 to the power n whole divided by, now p minus q, and p minus q will be 1 by 2, 1 plus root 2 to the power n plus 1 minus root 2 to the power n, and minus 1 upon 2 root 2, 1 plus root 2 to the power n minus 1 minus root 2 to the power n. Now we'll divide everything with 1 plus root 2 to the power n, and then we'll write 1 minus root 2 upon 1 plus root 2 as some lambda. So we can write this as this L will be equal to this limit n tends to infinite. This is 1 upon 2 root 2, 1 minus lambda to the power n upon 1 by 2, 1 plus lambda to the power n minus 1 upon 2 root 2, 1 minus lambda to the power n. Now this lambda, it lies between 0 and 1. So lambda to the power n, as n tends to infinite, it will be simply 0. So value of this limit will be 1 upon 2 root 2 upon 1 by 2 minus 1 upon 2 root 2, which is 1 upon root 2 minus 1. And if we rationalize, we can write this as root 2 plus 1. So value of L is root 2 plus 1. So value of L is root 2 plus 1. Now L square it'll be 2 plus 1 plus 2 root 2, which is 3 plus 2 root 2. Now we can write this 3 as under root 9 and we can write 2 root 2 as under root a. So value of a and b, they can be 8 or 9 or 9 or 8. Then the value of a plus b will be 9 plus 8 and which is 17.
Now the question is, we are given this function fx in terms of greatest integer function and fraction part function. Now when x is greater than 0, fx is defined as, so this first case, when x is greater than 0, fx is equal to this limit n tends to infinite px by n, and then this summation where r varies from 1 to n, and it will be this greatest integer function of r square plus r minus e to the power minus x minus 1 upon r plus 1 plus lambda. Now since r is an integer, we can write this as limit n tends to infinite px by n, and then this summation r varies from 1 to n, and we know that greatest integer function of x plus n is greatest integer function of x plus n if n is an integer. So it will be this r square plus r minus 1 and then plus this greatest integer function of minus e to the power minus x upon r plus 1 and plus lambda. Now when x is greater than 0, e to the power minus x, it lies between 0 and 1, and then minus e to the power minus x will lie between minus 1 and 0. So greatest integer function of minus e to the power minus x, it will be minus 1. So we can write this as limit n tends to infinite px by n, then this summation r varies from 1 to n and will be r square plus r minus 2 upon r plus 1 plus lambda, which we can also write as this limit n tends to infinite px by n summation 1 r varies from 1 to n and then minus 2 summation 1 upon r plus 1 plus lambda. Here r varies from 1 to n. Now this is limit n tends to infinite. This is px by n. Now this is n and this is minus 2, and we can write this as this summation r varies from 1 to n, and here it will be 1 upon r minus 1 upon r plus 1 plus lambda. So we'll write this as limit n tends to infinite px by n into n minus 2, and here it will be 1 minus 1 upon n plus 1 plus lambda, that we multiply it, then we'll get this as px plus lambda. So this function fx is px plus lambda when x is greater than 0. At x equal to 0, it is q. Now we need to find the definition when x is less than 0. Now if x is less than 0, it is given as this limit n tends to infinite, this summation r varies from 1 to n, fractional part of r square plus r plus e to the power x minus 1 upon r, r plus 1. Now we know that fractional part of x plus n, it is equal to simply fractional part of x. So we can write this as limit n tends to infinite. This summation r varies from 1 to n. All these integers, they will be removed. So it will be simply fractional part of e to the power x upon r, r plus 1. And also when x is less than 0, e to the power x lies between 0 and 1. So its fractional part will be same as e to the power x. So it will be this limit n tends to infinite e to the power x, and then this summation r varies from 1 to n, 1 upon r minus 1 upon r plus 1, which is this limit n tends to infinite e to the power x 1 minus 1 upon n plus 1, which is nothing but e to the power x. So this function will be q when x equal to 0, and it will be e to the power x when x is less than 0. Now it says it is differentiable in R. If it is differentiable in R, then it must be continuous at 0. And if it is continuous at 0, that means lambda equals q and will be equal to e to the power 0, which is 1. So value of lambda is 1 and value of q is also 1. Now it must also be differentiable. Now if we find f dash x, it will be p when x is greater than 0 and will be e to the power x when x is less than 0. So in that case, this p, it is equal to e to the power 0, which is 1. So the value of p plus q plus lambda is 3, and that's your option D. Now the second question is find the value of f dash log 2, f dash log 1 by 2, f dash log 3 upon 2 square up to infinite. Now we know that f dash x, it is 1 when x is greater than 0, and it is e to the power x when x is less than 0. Now at log 2, this value is positive, so this is 1 plus, now all these log 1 by 2, log 3 upon 2 square, log 5 upon 2 cube, this x is less than 0. So for all these, it will be this e to the power x. So it will be this e to the power log 1 by 2, e to the power log 3 upon 2 square up to infinite. So we need to find some of this series, which is 1 plus 1 by 2 plus 3 by 2 square plus 5 by 2 cube up to infinite. Now we'll write this series once again, leaving one term. So it will be this 1 by 2, 3 by 2 square, and we'll multiply it with common ratio, that is 1 by 2. Now if we subtract, we'll get this as s by 2, and here will be 1 plus, and this is 2 upon 2 square, 1 by 2. This is 2 upon 2 cube, 1 upon 2 square up to infinite. Now this is a upon 1 minus r, which is 2. So sum of this series is 4, and that's your option B. Now this third question is, if G is inverse of f, then G dash 1 by 2 is. Now we know that fx is e to the power x when x is less than 0. So if we look at f log 1 by 2, f log 1 by 2 will be e to the power log 1 by 2, and that is 1 by 2. So that means f log 1 by 2 is equal to 1 by 2. Now we know that if fx and gx, they are inverse function of each other, then g of fx, it is equal to x. Now we differentiate, we can write g dash fx into f dash x, it must be 1, and what we'll do here is we'll put x as log 1 by 2. So here it will be g dash and f log 1 by 2 into f dash log 1 by 2, and it is equal to 1. Now we already know that f log 1 by 2 is 1 by 2. Now f dash log 1 by 2. Now log 1 by 2 is less than 0. So f dash x is e to the power x. So it will be e to the power log 1 by 2, which is 1 by 2, and this is 1. So from here we can say value of g dash 1 by 2 must be equal to 2. And that's your option C.